Yes, Shira. Yes.
Okay, so what is the edits or edit log or transaction log or log? What it is? So when you do any operations with your cluster, the operations like creating a file or creating a directory or modifying it or you're renaming the file or data, file or directory, or removing them or appending the data, or or your um, uh, what are the transactions? You have created the directory, either you created a file or you are renamed it or you modified it or you appended the data or you remove. When you do these kind of operations, when you not read, guys, not read, when you only writing operations, when you do these kind of operations, we'll call transactions. Okay, when you do these operations, the entry will go into edit log. What the entry contains, who did, what is the operation, and that guy belong to which group, what are the permissions that guy has, when he has done the transaction, right? Like that, these transaction details will be, the logging details will be there in edit log file. Edit log file. Edit log file contains transactional details. It contains transactional raw details, raw transaction details. Transactional information. What are the transactions? Like who created the file, who modified it, or who deleted it, who updated it, what are the operation people will do, that transaction information will be going to edit log. The information will go into edit log, but the same information will be available in the RAM memory as well. The same information will be available in the RAM memory as well. Okay, so what is the information it contains? Like a transaction ID, the date, the who did the transaction, the user belong to which group, what is the transaction, all this information will be there in the edit log file. Okay, let's try to look at the edit log file. Try to look at the edit log file, but you cannot view in the, it looks, it'll not be in human readable format, and I think I have converted using some human readable format. Let me open some of the edit log file for you. I do remember I have did it sometime before. This is XML, this is FSIMAGE. I'll show you FSIMAGE later. Okay, okay, it seems that I didn't executed that. Yeah, fine, I can show you in my, what, when I have executed previous one, that copy is there, I'll show you from there. Let's look at edit log file. It's there in my drive. Guys, I have shared the videos yesterday. Please go through that. Anyway, I'll be sharing this information with you guys, so you'll also have a look later. Let me show you how edit log looks. How edit log looks. Yeah. So when you do a setup, you'll be doing a setup for your name node. Inside the name node, you'll be having a folder called current folder. Inside the current folder, you will be having like this edits, 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 edits. Okay, you will be having edits like this, and when you look at the area, any of the edit file, how it looks like this: edits, edit version and record, opcode, data, transaction ID. Inside the transaction ID, what is the operation? It's a make a directory, creating a directory, and transaction ID, length of it, and inode. Inode means address, and path slash output is the path, timestamp when it has been created, permissions when it comes to permissions, who is the user, he's belong to which group, right? So these informations will be there. There's another another operation is a add. What is the transaction ID? What is the transaction ID? Length of it, inode, address of it, path of it. What is it copying? And all this edit transactional information will be there in edit file. All the transaction information will be there in a edit file. And what is the block size? Let's look at here. What is the block size, right? What is the time, operation time? All the information will be available in the your edit log file. Are you guys clear about the edit log file? I'll show you FSIMAGE later. I'll show you FSIMAGE later. When you want to see in the real time, when once your setup is done, you guys also can see this. Look at you guys here. Once the setup is done your machines, you can also see this information. Where it will be there? It will be there in the name node. Where it will be there? It will be there in the name node. Under the current directory, it's loading. Actually, I have so many transactions, so many of the files. These many edit files are there. These many edit files are there. These many edit files are there. If you try to open and look at, if you try to look at the file of this, you cannot, because it is not in human readable format. You cannot. It's in a binary format. Okay. This is the edits. The location is where you have specified your name node directory. Inside that you will be having a folder called current folder. Inside that you will be having this edits files. Edits files means each will contain the some transaction information in it. Some transactional information in it. Clear? And edits in progress means it is the current edit file. If I'm doing some operations, that will be there in the current edit file. What are the operations I'm doing now? That operations will go into this file. These are all old edit files. These are all old edit files, and this is my current edit file. This is my current edit file. And if you see here FSIMAGE also, these are my old FSIMAGE files. And when I'm started merging this, I'll start merge with the new FSIMAGE file. You guys can look at here. You have very less FSIMAGE files, but you have so many edit files. Okay. Okay, when we done this setup, so in your missions I'll start explaining you all these details. What is the scene transaction? Scene transaction means it will contain the current transaction information. Version, it will maintain the versions, right? So all this information we'll see in the coming classes. Okay, try to understand what is edit log. Understand the edit log, what it contains? Any doubt, guys? Or could you please respond? Any doubts about the edit log?
No. So
Okay, yeah, let's move to FSIMAGE. FSIMAGE. So your edit log contains raw transactional information. That is the edit log. Log means when you do any operations with any application, at the background it will start recording each operation you do, from where to where it is navigating, from which page to page is navigating. All the information will be keep track of in the log file, right? The same way here we have something called edit log file. So why I have shown you the edit log file in XML file? Actually that's not in XML format, that will be in a binary format. So I have converted it into XML format. You can convert into text format, you can convert into different formats. I'll show you that operations how to convert the edit log files. Edit log file or edits file will be in a binary format, which it's not in a human readable format, which will be there in the name node, which will be there in the name node hard disk. It will be there in the name node hard disk. Let's look at one more FSIMAGE. What is FSIMAGE, guys? FSIMAGE, guys? File system image. File system image. It contains the file system information. It contains file system information. The file system information only will be loaded into NameNode RAM because it easily understand the file system information. How it looks, I can go ahead and look at the FS image. It looks here only you are able to see, right? Here only that FS image is there in the same location. The location is same, but look at the FS image file, how it looks. Look at how FS image file looks. Let me open all these files. This file does not have anything. This FS image as XML. When I have converted into XML, this is my FS image file, guys. This is my FS image file. Okay. So if image file will not be same for each and everyone, because I may have different data and you may have a different data. So the image file will be changed for different. Okay. Let's look at here. It's loaded as a XML only, but it's taken as a text file. So that's why it is not showing the syntaxes properly. Look at here. The same. Okay. I have some directories. Look at here, fs image name section, and it's not actually in the correct format. If I show it's in the correct format, okay, let me open that into, yeah, this is actually a binary format which will not look, you cannot view that binary format file. Okay, so when I convert into XML file, let me open this XML file into web browser. Let me open this XML file into browser. The browser will make it in a proper format. Yes, look at, guys, here. FS image, namespace section, generation timestamp, I mean generation stamp version 2, and allocated blocks, last allocated block, what is the transaction ID, inode section, directories, and user. My user is Hadoop 1. If you look at here, my user is Hadoop 1. Okay, Hadoop 1 at localhost. I mean localhost is means Ubuntu. My host name is Ubuntu, sorry. Okay, and let's look at directory is a temp directory. It's a have something called Hive directory. I have something called Hadoop 1 directory. I have something called user directory. I have something called, again, Hadoop 1 directory. I think is a different timestamp. Files. I have user info file. Let's look at, I'll show you, let me show you the proper. I have something called user details file. Look at, guys, here, inode. Okay, inode information. So what is the type of the file? File. What is the file? This. What is the replication? 1. And what, when it has been created? When it has been modified time it is. Okay. And preferred block size. What is the block size? And who is the user? Permissions. Who is the user? Who is the group is belong to? What are the permissions he has? Right? Look at here. And other block ID. It is a block ID. So each file will be into blocks, right? Each file will, the blocks will be having a block IDs, right? Right? And when is the generation timestamp? Number of bytes, size of the data. So this is the information. Actually, this information is different from your edit log for information. This information is different from the edit log information, right? So this information is required for your name node RAM memory, not the log information. That's why FS image will be loaded. Okay, that's where FS image will be loaded. You can take any file, guys. I have so many files has been EMP test. EMP test is one of the file. Let me check for the bigger file. There is something called bigger file. Yeah, bigger file. So this bigger file is very big file, and where I have so I think so 200 MB or 300 MB, where multiple blocks are there. To show you that, that's the only difference. Okay, I have a file. This is a bigger file .txt. Replication factor is 1, and when it is modified, and creation date, and block size, who is user. See here, if you see, there are so many blocks for this. Block 1, block 2, and block 3, block 4, block 5. For one file, how many blocks are there? And this is the block information. This is the block information. And if you take bigger file 2, this is also same, right? These are the block IDs. This is the file name. This is the type of the data. It is the ID of that inode, a path, right? Understand, guys, about the FSIMAGE? This information is required for your name node to understand what is my file, where and all the data is located. So where the data is located, look at guys here. I have shown you the edit log file, metadata file, but I have to show you the data also, right? There is something called data node directory. Inside the data node directory, you'll be having block pool. We'll talk more about this, not to worry as of now. Current, finalized, subdirectories, and these are the blocks. These are all the blocks. You cannot make out which block is belong to which file. Can you able to make out here? It will be having only block ID and the metadata of the block. You cannot make out any difference. Let's say this block. This block is belong to what file? I don't know. Let's take another block. This block is belong to what file? I don't know. No clue. No clue at all. Right? So even that's why I was telling you before, when you have a data nodes, when you know the data node is there, you cannot make out that data node is belong to what I mean, that data node has the data, right? The data will store in the form of blocks. You cannot make out that block or that data is belong to which file. Only who knows that information? Only your name node knows that information, no one else. Are you guys clear about the edit log and FSIMAGE? Edit log and FSIMAGE? Yeah. What about others? I mean, I'm hearing from only Sachin. So Anisha, Harika, Kishore.
Fine, sir.
Yeah, good. So this is about FSIMAGE and edit log. This is how they looks internally. You'll not get a chance to look at them because they are in binary format. They are in binary format. You will never get a chance to. I mean, you cannot read it. But there are on Hadoop too. There are few commands where you can convert them into human readable format, like a text file or XML file, where you can have a look of them. Understand, guys? Yep. Now this is how this edit log will take the actually it will not be there in the FSIMAGE, right? The information will be there in the edit log. From edit log it will take some information, then it will put into FSIMAGE. It will merge into FSIMAGE. In the FSIMAGE it will be in the correct format. It means actual data in the FSIMAGE. In the actual data in the FSIMAGE. Then that information will be loaded into name node, and that name node, these data nodes also will keep reporting him. When they reported, when the merge is done, when they reported, their name node will come out from the safe mode. It's also an important interview question, guys. What is a safe mode? What is a safe mode? Clear about this? Let's talk about data node. Let's talk about data node. Anyone, what is a data node? What is a data node? Guys, please talk, guys. So I want to hear from you guys. So I want to find out what is your understanding. So if your understanding is correct, it's good. If understanding is not correct, I want to fill that gap. That's how we need to update our knowledge. Are you guys able to hear me?
Yes.
Yep. So what is a data node?
A data node is a slave where a data is stored in blocks. It's
Data
a
node is
separate.
Yeah.
machine
Yes, it is a
that
separate
connected to
machine.
memory.
Yeah. Data node is a slave machine. Data node is a slave machine where the actual data will store into them, and the data will store in the form of blocks. The data will store in the form of blocks. Correct? Right? That's the data node. And the data node, as soon as it stores, and your name node maintains the information like file to block mapping, block to data node mapping. What is a file to block mapping? What is a file to block mapping? We have seen last classes in a few classes before. File to block mapping means the file, how many blocks has been divided, and those blocks where and all it is stored. Where and all it is stored. Okay, so let's quickly have a look of this information about your data nodes. Let's go here, Hadoop, that you go here, data. Let's look at here. I think we have discussed all these things, so I'll be sharing this, guys. I want to share this information we already have seen. Do we discuss about the differences? I think we have discussed it, right? Yep, we have
Yeah.
discussed.
Yes.
Yes. These discussions we have discussed about the differences, and we have discussed about, yes, do you remember we have discussed about these things also, scalability, these things also we have discussed. Yep. Let's move to Hadoop. This is history. Let's talk about history later, and let's move. Yep. Let's talk about. I want to show you. I will talk about these things, guys, and so I want to show you what is the. I know we're all seeing this. What is the DFS and what is the HDFS, and how your DFS process, how your data process in DFS, how the data process in HDFS we have seen, right? So now let's look at this is how the racks looks in the real time. This is how the cluster looks in the real time. This is called in-house cluster, or even in cloud also the same, guys. Even in cloud also this is the same. Okay, it'll not big change in the cloud. Even it will not be a big change in the cloud, because why we are calling it a cloud, they will maintain the servers, they will provide the service. We just need to pay them an access. This is how the racks looks. This is how the racks looks. This is the real-time cluster. This is how we'll make a cluster in the real time, and we'll be having a multiple racks. These are called racks. So many people have a different idea, I mean different opinion about the racks. So maybe they might have come up across some, there is some rack thing, concept in some, I think some Arkilla somewhere. Okay, this is how the rack is nothing but a one portion. This is a rack. See, this is a rack. There's a black one. This is a rack. These are the data nodes. These are the data nodes. I mean, not only data nodes, it can be one machine can be name node here as well. These are the nodes. Okay, let's talk about. This is the communication channels what we have seen last time. Let's look at. Yep, this is what we are talking about. Data node is a slave node. The data can be read and write in the HDFS files. The data will store in the form of blocks, and the HDFS has one or more data node with the replicated data in them. Replicated data in them. Data nodes are used to store the data in HDFS, and they store the data in form by blocks. The block maybe it is 64 MB or 120 MB, which can be configurable. Which can be configurable. What is the file to block mapping, guys? What is the file to block? As we have seen sometime before. What is the file to block mapping? Let's say I have a file called Amazon. Let's say I have a file called Amazon. Let's assume that the file size is 1 GB. The file size is 1 GB. How the data will store in HDFS? How the data will store in HDFS? Let's say these are the data nodes, okay? Please excuse guys, my drawing is too bad in these days. Okay, so name node, this is the data node, correct? Now you'll be having a client here, so client can be separate machine or it can be any of the data node. So I'll show you why is a client is separate machine. Now as soon as I have written a command called to put this Amazon data into HDFS, what is my command? What will I will write? Commands we'll see in detail when the setup is done. Hadoop file system put command, take Amazon data, put into /HDFS /data /Amazon. Let's assume that. As soon as I execute this command, the data will be divided into, what is my block size? What is the block size? 64 MB. Let's assume that. What is the replication? 3. So this file is 1 GB. This file is 1 GB. What will happen guys? So as soon as you execute that command, your client will divide this data into pieces. Break into pieces. Why it is breaking into pieces? Because it has to store the data into form of blocks and so on. Then this guy will take the first block. This is what we have discussed a few days before. Right or wrong? Right? He will ask the data nodes. Let's assume that he has given 1, 2, 3, and he will connect to this machine, and this machine will be connected to this machine. This will be connected here. What's the file to block mapping here? When you request a name node, the name node maintains Amazon file has been broken into block 1, block 2, and so on, and block 1 is stored in machine 1, machine 2, machine 3. Actually these are IP addresses, not the 1, 2, 3s. Block 2 is stored in 2, 3, 4. Block 3 is stored in 1, 2, 3, and so on. This is called file to block mapping. This is called block to data node mapping. Block to data node mapping. Clear guys? What is a block? What is a file to block? Do you guys understand what is a file to block? Okay. So coming to block concept, let's assume that I have my file size is 60 MB only, or 50 MB. My file size is 50 MB. How much space it will occupy in the HDFS? How much space it will occupy in the HDFS? My block size is 64 MB. My file size is 50 MB. How much size it will occupy in HDFS?
One block Viren.
150 MB. No, my file size is 50 MB only. 50 MB. My file is 50 MB. My block is 64 MB.
Yeah, but it will replicate, right? So it will be 3 copies of 50 MBs.
Oh, very good guy. Very good. So I didn't think in that way. Okay. Normally how much one block? I'm talking about one block, how much space it will occupy?
1 block.
Yeah. Now this is 50 MB. How many? So 3 blocks will come. Replication is 3 blocks. Forget about the replication. The block will occupy 64 MB or 50 MB. This is the block. Okay. The block size is my file size is 50 MB. This is block 1. Now this block 1 will be in a 64 MB size or 50 MB size?
Block will be 64, but storage will be 50, I think.
Exactly. That's what I'm expecting from you. It will occupy only 50 MB only. Some people will be having a misunderstanding or misconception, assumption about this. No, Shravani, it will not occupy 64 MB because the data is 50 MB only. Here, it will occupy only 50 MB memory. In this case, this block 1 size is 50 MB only. This block size 50 MB only. There may be in this case, let's assume that this because 1 GB. In this case, this block may be 64 MB because it's occupied full memory. Okay, but in this case it's only 50 MB. It will occupy 50 MB only, so there won't be any memory wastage. So many people will be asking this type of question. Ravi, you are telling the block size 64 MB. Let's assume that I have only 10 MB file. What will happen the rest of this 54 MB? It will not be wasted. For that block it will occupy only 10 MB space. For that specific block it will occupy only 10 MB space. Rest of the space will be free. It is like your normal hard disk only. Let's say you have 1 TB hard disk. When you're storing a 10 MB file or 1 GB file, it will occupy 1 GB only, right? The same way it will work in the real time also. It will occupy only 50 MB of the space. So don't get confused when say block is 64 MB or 120 MB. Irrespective of whether the data is there or not, it will not occupy 120 MB. It will occupy how much data it is there, that much only be treated as a block size. I have shown the FSIMAGE files, correct, right? So when you see an FSIMAGE file, when you saw a FSIMAGE file, it is occupying a full size or it occupying only some places you see the block size is this. Okay, sorry, the block, right? Some places you see the number of the block size is this, correct? But when you go with the smaller files, when you go with a smaller file, let me take some smaller file. This is FSIMAGE, guys. So normally we'll not get a chance to look at the FSIMAGE file. See here, this is some jar file. What is the size? It's very less. It's very less. It's in bytes. Let's take this number and convert into bytes. 4321305. 4321305 into 1, not into, divided by 1024 to convert into KB. Sorry guys. 4321305 divided by 1024 divided by 1024 into MB. It's a 4 MB file, right? It means how much file you store into your HDFS, that much space only will occupy, right? So let's take a bigger file. So I have shown you a bigger file sometime, right? Bigger file. Let's look at the block here. Let's look at this block size. So why I'm explaining this in this much detail? So you should be very strong in the basics. So even though if someone try to confuse you, don't get confused. Okay? So look at here. 33554432. My case, guys, I have changed the block size. Okay? I'll show you the configurations. Why I have changed the block size. I'll show you. It will be 32 MB. 1024 divided by 1024. What's my block size? 32 MB. Let's look at. Let's look at in my configuration file. Let me show you in a configuration file. Okay. In my configuration file, I have changed the block size. In my configuration file, it's changed. It's a block size is different. What is my block size? 33554432. 32 MB, because I have changed my block size. That's why it is storing 32. It can store 64 MB. It can store 120 MB, but I have changed it in my file. So that's why in my data it is occupying 32 MB only. Clear now? It will not occupy, even though if you have a less data, 10 MB, it will occupy only 10 MB. It will not occupy whole data, whole memory. Clear, guys? Yeah. Then let's look at this slide. So let's say you have a file called file.txt, which is 201 MB, and your block size is 64 MB. So how many blocks? 4 blocks. There are 3 64 MB blocks, and one block will be 9 MB block. That's it. It will not occupy more memory. It's not occupy 64, 64, 64. No. It will occupy how much data is you have, that much only it will occupy. Clear? So we just seen what is the name node. We have seen what is the edit log and FSIMAGE. What is edit log and FSIMAGE? we just talked about the name node. We just talked about the name node. One second. Yeah, we just talked about the name node. Name node is a master node and stores the metadata, single point of failure, namespace and all. And it will also be having the edits and FSIMAGE. We just saw what is edits and FSIMAGE. That's right. I have shown you what is how edit log file looks, and I have just shown you how FSIMAGE looks. Clear? Now, a question to you guys. What is the limitations of your name node? What is the limitations of your name node? Before going to the question, if anyone wants to read out, guys can read out. It is called it's a sequence of changes made in the system after name node starts. So once your name node is up and running, if you do any changes like you're creating, updating or deleting, that information will go into your transaction log or edit file. And what is FSIMAGE? Periodic checkpoints of the file system called FSIMAGE. It is a snapshot of the file system when the name node starts. It is a snapshot of the file system when the name node start. Right? Now the question to you. What is FSIMAGE? It's a single point of failure. Very good. So any other limitation? Harika, Anisha, Sachin, Masood. Hi Masood, welcome to our class. What is the limitations of name node? What is the limitations of name node? Guys, we have discussed so much about the name node. Try to find out the limitation of the name node. One is it's a single point of failure. What is a single point of failure? What is a single point of failure?
Vira, some disturbance is coming, Vira.
Is it my voice is not clear?
Your voice is clear, but some disturbance, some
No?
vehicle sounds also is coming.
No?
Yeah, now it's fine.
Okay.
Now it's fine.
One of our student is unmute, and that's the reason. Yeah.
Yeah,
Okay. Go ahead.
yeah, fine.
What is a single point of failure? What are the limitations of the name node?
Single point of failure means just, whenever the name node goes down, so we cannot access the cluster. So,
Yeah. Single point of failure means it is a single point. If like your name node goes down or it fails, you cannot access any data. You may lose data sometimes because the whole operations will be there in edit log and FSIMAGE, not in the edit log and RAM. If your name node burn out, it means you are not able to take the recovery. So that cases you may lose the data. Single point of failure means it's a only single point. If this is failure, you cannot access the cluster. As I said, we cannot access the cluster. That's the single point of failure. So any other limitations you guys see? What is the roles of name node? Can you guys find any limitation from the role of the name node? Raghu?
it saves some.
Yeah, go ahead,
Yeah,
guys.
it saves some metadata.
Hmm.
It saves the metadata. So, whenever the name node goes down,
Mhm.
so the metadata, whatever the, client which is sending for storing the data, that metadata will not be collected by name node. What during that downing, down stage,
Okay, okay,
that will be lost for name node.
okay.
So
So
that is the
what is the
limitation.
name
Another
node
one,
role? What is the name node roles and responsibilities of the name node? Anyone,
it
guys?
just,
Even yeah.
it collects the, metadata and stores in it.
Okay. Anyone else? Masood, Raghu.
It also monitors the cluster and the data nodes.
Okay. So when name node restarts, what will happen? So let me give one hint. So when a name node restarts, what will happen?
It gets the data from secondary name node data. I mean, if anything
No,
means
we're
the
not
FS image and
exactly. See here, this one. So when a name node restarts, what will happen? It will read the edits. It will try to merge with FSIMAGE. Read the edits and it will try to merge with the FSIMAGE. Right? If your edit log is huge, let's assume that I didn't restart my cluster for a long time. If my edit log is huge, the merging time will take the merge process will take some time. When it's doing a merging, your name node will not be available. You cannot do any write operations. That's also one of the limitation or not, right? Let's look at here. When in use, all the information stored in the main memory, but this information also stored in a disk for persistent storage. Persistent means permanent storage. Name node is the central point of HDFS and is a single point of failure. Name node responds to the client request and return the corresponding data nodes for a file request like IP address and all those things, right? When you see limitations, edit log become very large when will be challenging to manage. When it will edit log will become large because you wouldn't restart. You have so many operations you are doing. You have only one cluster. There are testing team is doing, QA team is doing, development team is doing, production team, and the real time. All the data is going to talking to single cluster only. Let's assume that. So many transactions are happening. So many transactions, billions of transactions are happening. So that time what will happen? Your edit log will become huge. When the edit log will become huge, it is challenge to manage. The name node restart takes long time because lot of changes has to merge with FSIMAGE. The lot of changes has to merge with the FSIMAGE. In case of crash, we will lose or lost huge amount of metadata since FSIMAGE is very old. Right? I didn't start for 3 months. Let's assume that 3 months before my FSIMAGE is there. Now the latest FSIMAGE is not there. It's not yet created. It will create a name by name node. When it will create? When it restarts. But I didn't restart from last 3 months. So this is the limitations of your name node. One is a single point of failure. When you do a transaction for a long time and you didn't restart or you don't have anything other configured, your edit log will become huge and it's very difficult to manage. And when it restart, because of the huge edit log file, it has to merge with FSIMAGE, who will take more longer time to restart, and that time your cluster will be safe mode. That time your cluster will be in a safe mode, right? Let's look at this is what I have shown in the previous slide, and this is how edit log will looks. This is how edit log looks. This is how the FSIMAGE will look. The FSIMAGE as a text file. You can also look the FSIMAGE as a text file here. And to overcome that issues, to overcome the limitations, we come up with a secondary name node. We come up with a secondary name node. Okay, so we'll talk about the secondary name node tomorrow in a detail. Okay, so please go through the other things. We'll talk about the secondary name node very detailed, and I'll explain what is the secondary name node, how it will solve the problem. We will see tomorrow. Any doubts? Please stay back, or you guys can leave for the day. Any doubts? Please stay back, or others can leave for the day. Yeah, what I was talking of previous also, I was telling you data node has two file systems. One is a HDFS, one is a local file system. Even if you go the DFS, multiple machines are connected internally. On top of that, there is one layer will be formed. Okay, that doesn't mean that you are storing data in some different way, different other place. You are storing into computer hard drive only. Here also, when you say HDFS, HDFS is on top of your data nodes file system. Data node will be having a file system like your operating system installed. On top of that, this is a different layer. It means the data is storing into your machines only. Data is storing in your data nodes hard disk only. right? Let's take, this is my Linux box. My Linux box has local file system where I can say ls, or where I can say any commands here, mkdir and all. This is a local file system layer. If I'm doing ls or some operations here in the direct disk console, this is local file system. Suppose if I'm doing Hadoop fs -ls, if I'm doing something like this, because my services are not up, so if I do this command, it will try to look at in the HDFS layer, the different layer, to try to look at in the different layer. Actually my services are not running, okay, not to worry. Okay, so if I start the services, it will be, let me start. Now, so two different layers altogether. One is a local file system layer, one is a HDFS layer. Both the layers will be where? In a data node only. It will be in the data node only. If you're loading the data into your desktop, let's say you are loading the data here. You're loading this data here in the local, was wherever it is in the hard disk. It is going to hard disk only. And also I'm loading some data here by using Hadoop command. The data is going to Hadoop only. NAMENODE is still loading. Because your machine is still running. Yes, it's up and running now. It's up and running. Let's look at here. This is what I have shown you. Temp, user, Vira, Hadoop. These are all my HDFS data. This is Hadoop data. Bigger file 2. This is my Hadoop data. This Hadoop data I cannot see in here. I cannot see here. I cannot at all see here in this. I cannot see at all here because that's a different layer and this is a different layer. Whatever the data is there in this, let's say I have some data here which is called let me show you something here. Yep, MR input, MR output, something is there here. This data I cannot see in HDFS because that's a different layer. It won't be visible for me. Right? It won't be visible for me here. But this data, whatever this data is here, that also will not be visible here. I cannot go ahead and look at here. I don't have any command. If I want to talk to HDFS layer, yes, I need to write a command like Hadoop fs-ls. This is, I'm trying to fetch the list of files, a list of directories of Hadoop. Okay, suppose if I want to get the local file system list of directories and files, I can just say ls. See the difference? This is different layer, the top one, the below one is different layer. Okay, this is what we have discussed couple of days and this is what we have seen this thing. Yeah, good.
Yeah, thanks for the demo.
So any other doubts, guys? I love to hear. Okay, if anyone asks, I love to explain because you are showing some interest towards our class, right? You are showing interest, so I'm very much happy to answer you. If I don't know, I will learn or I will look at and I'll come back to you. It doesn't mean that everything I should know, right?